Hello! Today we are going to take a field trip all the way to Canada in the region of Taber and Barnwell in Alberta. And we are going to look at a before and after storm imagery. And in this area, there's a large production of corn and other crops. And so analyzing the crop fields before and after a storm can be really important. And so we're going to use this as a practical example for today's exercise. As 1, 2, 3 for red, green, and blue. But we want to change that to a natural color. So according to Landsat data, that's 3, 2 for the green band, and then 1. Okay, and we're going to do that for after as well. And so you'll be able to see the difference once I change these band combinations. 3, 2, and then 1. So they look more natural. They look as if what we would see in the visible spectrum with our naked eye. Okay, and now we're going to compare the before and after images by running a SAVI. So now that we have changed the band combination, I want to just visually assess the images. So I'm going to go up to raster layer and select swipe. And we've used this tool in the past in some of our labs. And then I'm going to just move the after storm image so I can quickly see what it looked like before. And so visually speaking, there is some difference, right? Like you could see the crops aren't as vibrant green. There's more bare soil. So there was a change because of this storm. And that's obvious using the swipe tool and just looking at the image. But now we're going to actually assess it using the SAVI index. But before we do that, I also want to take a look at the spectral profiles. And to do that, I'm going to take a look at the spectral profile graph. So to get a better sense of the variability of the red and near infrared band reflectance values, we could take a look at the image information tool. So to do that, we're going to go to imagery, and then let's select image information. Okay, so I've selected the image information, and I want to go back to map and make sure I'm on the Explore tool. And we could be on either before or after. We could just be on after for now, but you can see as I'm moving across the image, the spectral profile, the graph on the right, is changing. So if I zoom in closely, and this is changing per pixel, the bands are displayed on the graph in the order provided by the image, which is blue, band 1, green, band 2, and red, band 3. And then near infrared is the gray, so it's the 4th band, which isn't visible to the naked eye, but we still have this data because we've collected it from the remote sensing sensor. Okay, so let's point to a beige or light brown area. I can zoom in even more. And so this is corresponding to bare soil and the absence of vegetation. And then in the image information pane on the right, you could see the spectral profile graph has updated, and that near infrared gray band is way smaller than what we were seeing when we were over the dark green. The red band reflectance value is now comparatively higher, and the near infrared reflectance value is lower. So then if I go, let's zoom up to this dark green cornfield. Wow, you could see the near infrared gray band has just like tripled compared to the bare soil. And that near infrared, and that red band has a much smaller value. So go ahead and point to more areas of both images and observe how the red and near infrared values vary. So we can go to vibrant green, that's even a higher near infrared value, so that's even healthier vegetation. And then again, the bare soil is much smaller. So now that you can better understand the relation between the two bands, you could see that computing the gap between these red and near infrared values could be a good method to measure the amount of healthy vegetation present on the ground from before and after the storm. So we're going to do that using the SAVI index. So we'll actually compute it with a mathematical formula and come up with numbers and so on. So let's go ahead and zoom out. And so to apply the SAVI index, we want to make sure the before storm is selected, and let's just uncheck the after storm. And then on the ribbon on the imagery tab in the tools group, so navigate to tools and then click indices. So in the indices pane, select the SAVI, and there are a ton of different indice analysis you can use in ArcGIS Pro, but for today we're just going to do SAVI. And if you hover over it, it'll share some information about the analysis, the index rather. So go ahead and click that. And then we want to choose the following. So for the near infrared band, that's going to be band 4. It's that gray band that we were just looking at in the spectral profile graph. And then for the red band, we want to choose band 3. And then for soil brightness correction factor, we're just going to keep it as the default, which is 0.5. And then select OK. And a new layer called SAVI_before storm, it's a TIFF layer, appears. And so unlike the original satellite image, this is not a multispectral image. It's not multiband. Each raster cell holds exactly one numeric SAV value that summarizes the healthy vegetation status at this location. So, and also this index tool is a raster function, which means that the resulting layer is computed dynamically. It is not saved on the disk. So since no intermediate data sets are created, it's actually a lot quicker to apply these changes. Okay, so we have our before storm. Now let's uncheck that and then click the after storm. Let's make sure it's actually selected in the contents pane. And then we're gonna run the same tool with the same information. So go to indices and SAVI. And so near infrared band is band 4 and the red band index is band 3. Keep the default of 0.5 and then select OK. Okay, and we have a before and after SAVI index TIFF layer. And so let's drag from top to bottom to reveal the SAVI storm image. So to do that, let's just take a look, scroll out, and then let's go to the swipe tool and see if we see any differences. And I zoomed out too far. So I'm going to swipe down the after. And right away, we can tell that there are differences between these two TIFF layers, between the before and after index, SAVI index. And to what value, we don't know that at this moment, but we're going to compute that. So we could see there's a difference, and so there's further analysis to be done. So when you're done exploring with the swipe tool, you can go up to Map, and then in the Navigate group, click Explore, and that'll exit out of swipe. And let's make sure to save this project. I haven't saved yet, which is a great example to go ahead and save. Cornfield damage. Okay. Okay, always a good habit to save early and often. The next part of the lab analysis is to compute the change between the two SAVI layers. So we actually have another layer that shows this difference. So to measure the change in vegetation caused by the storm, we will compute the difference between these two layers using the raster function called compute change. And so last week we were familiarized with raster function, which is if you go up to imagery and then select raster functions. And here you could see there's a lot of different processing tools you can use for raster layers, but we're going to use the one called compute change today. So let's type in compute change, go ahead and select it. And so we're going to find the difference between the SAVI after storm and SAVI before storm. And then a resulting positive value will signify a loss of healthy vegetation. So on the pane on the right, let's select from raster to be after. So SAVI after, and then to raster should be the SAVI before, and we want to compute the difference. And then we will keep the default of cell size to be max of, and then intersection of, and then select create new layer. And now the new raster layer compute change SAVI after underscore storm.tiff. It's actually quite a long name, which you're welcome to rename. But so this new resulting layer appears, and the areas in purple tones indicate a loss in healthy vegetation. And you can see that if you go to the symbology pane of this new layer, and you can change the symbology color scheme, but I'll just keep it as the default. And so the purple are higher numbers. So those are positive numbers, which indicate a loss in healthy vegetation. So you can visually inspect this layer now that the color scheme is obvious. And so if we take a zoomed out look at this, let's turn these off so it operates a little quicker. We could see that perhaps the storm went across this area diagonally, because you could see the most loss of healthy vegetation is from the northwest corner to the southeast corner. And then we also see some down here as well. But then we see green in this image, which would indicate a vegetation growth of some sort. And this can maybe be attributed to the fact that there was some rain, maybe there was seeds in the ground and it sprouted new growth. But so the green area and anything below 0, these negative numbers, we're not interested in, because it's not showing the impact of the storm on the cornfields, right? So the small gains in vegetation are not relevant to us in this analysis. So we'll want to eliminate all the values below 0 in the raster with what we're going to call the remap raster function. And so let's go back to raster functions and then type in remap. And go ahead and click it. And in the remap properties pane, enter the following parameters. We're going to select compute change SVI, so that layer that we just created. And then for the remap definition type, we're going to keep this as list. And then we'll express with a remap rule that all negative values in the raster should be removed, that is, be changed to no data. So we don't want to have any of the negative values in our analysis. As seen in the contents pane legend, the lowest value of the layer is negative 0.576915. So we'll use negative 0.6 as the minimum value. So for minimum, enter negative 0.6. Okay, and then the maximum we'll keep 0. And then for no data, check make sure the box is checked. Okay, just like this. And then create new layer. So now a new raster layer called remap compute change. It's quite long. You can rename it if it's easier for you to identify it. We will uncheck that previous layer, and now you can see the green values have dropped off this layer. Oh, and I have red showing because they're field boundaries, which we can unselect those. And so now we see just the positive values. Okay, and so let's be sure to save. So come up here in the top left, hit save. So now this new layer shows only the areas where there has been loss in healthy vegetation. So dark purple would indicate the highest positive number. So you see a lot of impact to these cornfields in the northwest corner, and then slowly kind of dissipates as you go further southeast. So now we're going to extract the average vegetation loss for each field. So we want to know on average how much damage has been to this area, has impacted these cornfields. So we're going to compute the average loss, and to do this, you'll use the field boundaries, which I just selected unchecked. So let's click that on, and let's drag it to the very top of all the layers here. So we could see, you could see the field boundaries, and that's kind of a thick boundary. So I'm going to change the outline width to just 1. Okay, so that's a little better. So the polygons represent the cultivated fields symbolized in red. And to compute the average vegetation loss, you'll use the zonal statistics as table tool. So for each field boundary polygon, the tool will calculate the mean value of all the pixels in the loss of healthy vegetation raster that fall within that polygon. So go up to Analysis, and let's select Tools. And we want to go to the geoprocessing pane that appears when we select the Tools icon. And then let's just type in zonal statistics as table. Okay, and it's that first box, so go ahead and click that. And we're going to enter the following parameters. For the input raster or feature zone data, we're going to select field boundaries. For zone field, keep field ID, which was populated automatically, so we'll keep the default. So for the input value raster, we're going to select the newest layer where we removed the negative values, and that's remap. And I would suggest renaming your layers so that you know what you're looking at rather than these really long names. I didn't do that in this case, but if you're doing this after this tutorial, I would recommend renaming the layers so they make more sense. Okay, and then for output table, we're going to type vegetation loss table. So let's just name it what we'd like right now. So you just remove that last part after the very last backslash, and let's type vegetation underscore loss underscore table. Okay. And then for ignore no data and calculation, keep the box checked. And then we'll select statistic types to be mean because we want that average. And then we'll keep these unchecked. Okay, so now select run. And the output of this tool is going to be a table. And then you could see this exclamation mark. That's because this table already exists. So it's telling me like this name already exists. It will be overwritten, but we don't need to run this tool again. So we can press the X there. So if you go to your contents window and you scroll all the way down to the standalone tables, you'll see vegetation loss table. So let's click that open. So right click on the table and select open. It contains one row for each cultivated field, so each cornfield polygon. The mean column gives the mean of healthy vegetation loss for each polygon. But we want to have this data in the field boundaries table so that we can then symbolize it. So what we want to do is close this table and go back to the contents window and right click on field boundaries. And then select joins and relates, and then add join. So this will pop up the add join tool, and we want to input table to be field boundaries. And then for input join field, we want to choose field ID. And then for join table, choose vegetation loss table, which is already there. And then for join table field, select field ID. So it's going to join those field IDs together and then add that data from the new table we just ran to the field boundaries. So then select OK. So the mean value has now been added to field boundaries. So if we click this field boundaries layer open, so click attribute table, it'll pop up on the bottom, and now you could see the mean values for each polygon. So if we even right click and zoom to this polygon, highlight it, we could see that the mean is 0.25. Okay, so we could go map and then clear, so we don't have anything selected. Okay, so we have the information in the attribute table that we wanted, but so now we want to symbolize this. So let's right click field boundaries and zoom to layer. And then in the symbology pane for this field boundaries, we're going to change the primary symbol. So right click field boundaries and select symbology. And you can turn off these layers if it's slowing down when you turn things on and off. So I think that looks good. Okay. So now over here on the right in the symbology pane, we want to select graduated colors. There we go. Okay, and then for field, we're going to choose mean because we want to have the mean value symbolized. For method, ensure natural breaks. So that's already selected. And then for classes, let's choose 4. We don't want 5, so we'll just do 4. Okay. And then for color scheme, let's do the yellow to red, which is already showing, which is great. And then let's make sure to turn the remap this layer off that shows all the purple. Okay, and so on the classes tab over in the symbology pane, let's click the label value for the yellow class. So that's this one. And we're gonna write low, because these are low values. And then this one, the orange, we'll select medium. And then for orange red, we will type high, not select. And then for the red, the highest number, we will select very high. So these are very high index values. Okay, and so let's observe the final results. The fields that appear to have experienced high and very high loss in healthy vegetation are clearly concentrated in the northwest corner to the southeast axis, but the most being impacted in this northwest corner where the storm hit. So the fields with low loss are mostly concentrated in the upper right over here, and then also the lower left corners. And you might also observe some neighboring fields with different damage levels. You can see over here and a little bit on the outside on the left. This could have many causes. For instance, different crop types could be affected differently by a hailstorm. Also, two fields with the exact same crop, but each at different level of plant maturity, could also be affected differently. So this map offers a first assessment of the damage, a really great visual assessment now that we've also symbolized it with graduated colors. And it could be used to guide a more detailed inspection on the ground. So you could use this to do a field survey. Okay, so you can hit save. And in this tutorial, hit save. In this lab exercise, you observed before and after storm imagery in natural color, so in the 3-2-1 band combination, and explored the pixel spectral profiles, which is a repeat of some information that we learned about weeks ago. And then you learned about the importance of red and near infrared bands to assess vegetation health. And you learned what the SAVI index is. And so you applied the SAVI index to both images and then computed the difference using geoprocessing tools between the two resulting rasters. Finally, you extracted the average loss of healthy vegetation for each crop field and created a map that provides a first assessment of the crop damage that was caused by this storm. So to complete this lab, make a map of the crop fields showing the mean SAVI index numbers, not numbers, but the mean categories. And then somewhere on the map, provide the answer to the following question. Which cornfield, so field ID, you could see that in field boundaries. If I open up this attribute table, so which cornfield has the highest vegetation loss from the hailstorm? And you could answer it using the field ID. Okay, remember your 5 essential map elements, and you can use imagery, aerial if you'd like, or a base map of your choosing, and then upload it to Canvas. Thanks.